Math 2, Unit 12B, Section 4. Today we're talking about complex numbers. This is something that you may not have seen before, but teachers may have talked about it before. When you are taking the square root of a number, if you end up with a negative under the root, it's not a real solution. It's actually called an imaginary solution, okay? Which makes it a complex number, okay? So what happens is that anytime you end up with a negative under your root, we just take that negative and bring it out, and it becomes an I, which stands for imaginary, okay? Meaning not real, okay? Some of you might have imaginary friends. They are not real, okay? Yes. Some of you, maybe that's the only friends you have. I don't know, but, you know, whatever. Okay. All right, so anyways, I didn't say any names, all right? You know who you are, though. Okay, anyways, I'm totally kidding. Okay, back to math. Okay. So, negative under a root. So basically, going back up here, the square root of negative 1 equals I. And again, it does stand for imaginary, okay, which would make sense. Imaginary starts with an I. Yeah, I know, crazy. Okay, there is one more rule though with, so if we have a negative under a root, we bring it out and make it an I. The other thing that is super important, and you want to make a little star next to this, is that I squared equals negative 1. So, here we go. Sometimes it's just easier to go through and figure it out than to talk about it too much. Okay, so we are going to simplify these. I's are just like any type of variable where if you have more than one of them, you can combine like terms. So on this first one, do you see how it's adding? All we're going to do is combine our like terms. When you are writing these answers, you normally write the real part first, meaning the part without the I, and then the imaginary part second, okay? In this case, my I's, I can combine my like terms. What happens with them? They end up canceling out because 2 minus 2 is 0. And so these cancel out, and so the answer for this first example is just what? Negative 4. Okay. We're going to go to this next. Oh, go ahead. Question? Because like x minus x, 0, cancels out. Same thing. Okay. On this next example, going down, please try to focus and not talk to each other, Dustin. Okay. What do you think I'm going to do first? Distribute the negative, okay? And so I'm going to rewrite this. We have 3, and negative and a negative make a positive 2, and then a negative and a positive make a negative 3i. And then if I distribute a positive through, it doesn't change things. So I'm just going to end up rewriting a minus 5 and a plus I. Now, I already mentioned this, but normally when you're writing these answers, you write the real part first and the imaginary part second. And so we're going to combine our like terms here. And I like to go through and kind of circle or box what I'm combining together. We have a 3. We have a positive 2. Pay attention to your signs. And then, oops, I kind of drew over the I there. And a negative 5. So when I combine those together, what ends up happening? They end up canceling out as well. Okay? And then I have a negative 3i and a positive I, which makes what? Negative 2i. So all we're doing is combining like terms. Think of the I as just a regular variable that you're adding. Okay? All right, next one. This is where it changes a little bit. Okay, so make sure you're paying attention, ask questions if you're unsure. Again, we're still going to distribute. So what is 4i times 6? 24i, good. And then we have 4i times negative 2i, which would make what? Okay, negative 8i squared. So then what I do is I know that I squared, anytime I get I squared, it actually equals what? -1. And so I'm going to end up simplifying this. So this is -8 times -1, which actually makes what? +8. Okay, so now I have a +8 and a 24i, and we write our real part first. So my answer will be 8 plus 24i. Because this part right here simplified to be 8. Yes?
Why didn't you write the real part?
That's how complex numbers are written. And it says back here, a complex number has a real part and imaginary part. And so they, just in math, they write the real part then the imaginary. If you flipped it around, I wouldn't mark you wrong. Okay? All right. Do we have questions on this? We're okay? All right. So now we're going to move on. Notice that we...
Sorry.
Okay, we have 2 parentheses here, and so we need to use our distributive method, or we can use our box method. So which?
Distributive.
Okay, so distributive method. Okay, so we start, we're going to go 3 times 2, which is 6. Okay, 3 times I is a +3i. Christian. Michael. Okay, I times 2 is a +2i, and then I times I makes a I squared. And I like how some of you already remember that's -1. At this point now, I usually go through, and if I have an I squared, I end up changing it. Okay? And so I'm still going to write this. I have 6 plus 3i plus 2i, and then this right here is going to become what?
-1.
Very good, -1. Because I squared equals -1. We learned that back at the beginning. Okay? And then we're going to write our real part first. And so I have 6 and -1, which makes 5. And then I have 3i and 2i, which makes 5i. And that is my answer. Do we have questions? Okay, I'd like you to use the distributive property or your box method if you choose, and try this one on your own. I'm going to give you about 1 minute to get that answer. If you have the answer, raise your hand and I'll show you. Or check it, I mean.
Are we doing the ones with choose?
Yes, the one with the 2 parentheses bullet that starts with 4.
Caleb, you're cheating.
Perfect. No, that's good.
That's good.
Perfect, good job.
Actually tried once. Deep breath. Anybody have questions?
I got it something.
Cameron did it.
Okay, it sounds like most of you have it. Here we go. So, we are going to start by distributing. Okay, I need you guys to get focused. 4 times 1 is 4. 4 times 2i is 8i. 3i times 1 is 3i, and then 3i times 2i makes 6i squared. Okay, any I squareds, we go back through and we end up changing them. Now, that actually means 6 times -1, which makes a -6. So, I have 4 plus 8i plus 3i minus 6. Okay, we always try to do our real part first. So, I have a 4 and a -6, which make -2. And then 8i and 3i make 11i. Any questions for me? Okay, next one. I'm just going to give you about 20 seconds here. Combine like terms. Get the answer. Okay, give me a thumbs up once you're done. Okay, good. Thank you. Thank you. Okay, so real part first. 5 and negative 2 make what? 3. 6i and 4i make. And that should be your final answer. All we're doing is combining like terms. There weren't any I squareds in there that we had to change. Okay? All right. Do we have questions? Did you guys, there weren't parentheses being multiplied together there. They were just combining like terms, just adding.
That's in that.
Okay. Do you guys remember? Okay, we are not going to have Mix It Up Monday if we cannot be quiet. Okay? Do you guys remember previously when we would have a root in the denominator? Like, let's say I had 3 over root 2. That was not okay. We cannot have roots in the denominators. And so what would we do? Very good. We would end up multiplying by root 2 in order to rationalize the denominator. And we ended up getting 2 on the bottom and then 3 root 2 on the top. Do you guys all agree with that?
Yes.
Okay. What does I actually equal? The square root of negative 1. So if you have an I in the denominator, that is not okay because that's basically saying there's a root in the denominator. Do you guys understand what I'm saying?
Yes.
Okay, so we're going to put a little note here. We cannot have an I in the denominator. So the one thing that's nice about i's that we know is that I squared ends up making it negative 1. So how here I multiplied the numerator and denominator by root 2, when we're dealing with i's, what would I end up multiplying by? If I have an I in the denominator, I'd need to multiply by an I. Okay, because we know that I times I makes I squared, and I squared is actually negative 1. So on this problem right here, since I have an I in the denominator, in order to eliminate it from the denominator, I multiply both the top and the bottom by I. Okay, so my denominator, and we're just going to write this out right now. I times I makes I squared. I'm just going to write it as I squared so I can see what's happening. This means I have to multiply everything on the top also by I. So I end up with 2i plus, good, 2i squared. Okay, and so now we're going to go through and change anything that's an I squared. Okay, and so this I squared is going to end up becoming what? Negative 1. This 2i squared is going to end up becoming what? Negative 2. And then we're going to rewrite this. Okay, the real part should go first. So I have negative 2 plus 2i all over negative 1. And could I end up simplifying that? Yeah. So this negative 1, yes, Denise. 2 times negative 1 is negative 2. So this right here, what that actually means is 2 times negative 1. Just like this I squared just means negative 1. Okay? And so this, the negative 1 goes with both of these. And so how would I end up writing that answer? What's negative 2 divided by negative 1? Positive 2. What is 2i divided by negative 1? Negative 2i. Okay, and so that would be your final answer there. Are we okay with that? Do we have questions? Okay, this has a 3i. A 3 in the denominator is fine. What is not okay in the denominator? An I. Okay, so we are going to still multiply the top and the bottom by I, because I is the only thing we need to eliminate. So I'm going to go ahead and do this again. We're going to multiply the top and the bottom by I so that we can eliminate the I from the denominator. When I do that, we have to distribute the I through everything on the top. Right, Christian, Albert, Josh, Samir, okay? Here we go. So we get negative 4i minus I squared in the numerator, or on top, divided by 3i squared in the denominator. Is everybody okay with that so far? Yes? All right. Now, any I squared that we have, we know that it actually represents what? Negative 1. So this right here, instead of being I squared, it's really a negative 1. This I squared is really a negative 1. So I'm just going to kind of write this out here again. We have negative 4i, but what's a negative and a negative make? So that's a positive 1 over negative 3. Can this one be simplified?
No.
No. So we can just leave our answer just like that. The only thing that I would end up changing though,
There's the Y.
very good, is I would probably end up writing this as 1 minus 4i over negative 3. Okay, do we have questions before we move on to the last example? Okay, do you guys want to give this last example a try on your own? Okay, so you should be doing this one here on your own. And that's a 6 plus I over 2I. Okay. So the correct answer should have been something like negative 1 plus 6i over negative 2. So let's go through that. The first thing you should have done is multiplied both the top and the bottom by I. When you do that, I'd appreciate you being quiet. And we get 6i plus I squared all over 2i squared. We know that I squared actually represents negative 1, so I'm crossing these out and putting a negative 1 there. So I end up with 6i minus 1 over negative 2. Now, you could separate these every time if you wanted to as two fractions. 2 does go into 6i, but it just makes a fraction on this one. And so I would just leave it how it is. But I would rewrite it to be -1 plus 6i divided by -2. You also could put the -2 through here, and you might even see it as +1 minus 6i over 2. That answer, does that make sense, how I'm distributing the negative through the top? So both of these answers are correct. It just depends on how you want to write. Okay, any questions?